Hello everyone, welcome to Melbourne CocoaHeads number 152. My name is Hugh and I'm your host tonight. In the spirit of reconciliation, Melbourne CocoaHeads acknowledges the traditional custodians of country throughout Australia and their connections to land, sea and community. We pay our respects to their elders past and present and extend that respect to all Aboriginal and Torres Strait Islander peoples today. Tonight we have two talks and then we've got a bit of a Zoom catch up. We've got Matt Delves. Matt's a regular to CocoaHeads and they've come back tonight to talk about spotlighting under the core spotlight. Rob Amos, dependency injection with a service locator pattern. We've been talking about that on Slack and I'm excited about it. Did I just say I'm excited about dependency injection? I did. I'm not going to apologize. After that, Zoom. This is a regular thing we do, but I want more people to come. So come along to a Zoom catch up afterwards. I'll post a link on Slack. Code of conduct. If you're being harassed or notice someone else in an uncomfortable situation, this is what this is for. We've read it out before. Here it is again. The long version is available at that URL, but we want everyone to be happy. Gold sponsor tonight is Itty Bitty Apps. Without them, we probably couldn't really pay for all the things that we pay for with everything that we do. So thank you very much for Itty Bitty Apps to pay for that. Silver sponsors, REA Group, Latitude Financial Services, and Cognizant. Next thing we're having, this is tonight, but the next thing we're having is on Tuesday, the 23rd of November, the Imperial Hotel Rooftop Bar, CocoaHeads Drinks Night. You can register on the, because I'm not sure how many people we're allowed to have, but you can go onto the Drinks Night channel in Slack and tell us if you're coming and then book yourself a spot. It's pretty fun. And after that, on the 4th of December, we haven't really seen each other that much this year. It's been a bit of a strange year, like last year. So like last year, we're going to have an end of year catch up, family day, casual afternoon in the park on Flagstaff Gardens. We're going to have a barbecue, bring anyone you like, your family, kids, whatever. And we'll just have a quiet afternoon in the park, just getting to know one another a bit again. Other groups, sydneycocoaheads.com, they usually broadcast a week after us. They're on next Thursday. GDG Melbourne, they've got more information at their website there and the web meetup. They've been going along strongly during lockdowns as well, so just go and have a look at them if you're interested in those topics. And how to find more about us, melbournecocoaheads.com. You probably already found that. If you're not on the Slack, jump onto the Slack. You can get an invitation to the Slack at melbournecocoaheads.com/Slack, and we'll be talking about this meetup on the meetup channel. And we've got a Twitter. If you can follow us on Twitter, we'll post regular reminders about events and so forth. More about Slack. There's lots to do on our Slack. We've got the meetup channel to talk about the meetup. So ask questions there and the speakers will be there to answer them. We've got a volunteers channel. That's the organization stuff. If you want to help run CocoaHeads or want to ask questions about how CocoaHeads is run, go on there. Jobs, that's if you're looking for work or looking to hire, go to the jobs channel. And speakers. If you want to do a talk or just you want to help to make a talk, we can help you. Come onto the speakers channel. Apps we've shipped. So this is apps that Melbourne has shipped. We're always really proud to spruik what Melbourne has shipped. Firstly, Reveal has shipped version 32. It's got a few new cool features. One of them is just right-clicking on a view or on a layer node, and you can export that. So that's really handy for designers. Or you can just show them just one view or layer. And it's also got big performance gains. Like last version, they've just done another big cleanup and got heaps more performance out of it. It's great. And Linked, this is sent to me by Alexi. They've just improved validation of license plates and improved messaging. It's a solid little incremental update. Good on you. And Rhino, this is by Vlas, and Matt. So they've put a heap of work into Rhino version 2. This is for your MyKey card, and you don't even need accounts anymore. It just scans it via NFC. It's pretty cool. It's a great app. Go and check it out. If you use MyKey at all, this is a really helpful app, I've got to say. If you've shipped an app, tell us in Slack. We want to see it. We want to congratulate you for it. And thanks very much. The first talk under the core spotlight, Matt Delves.
Evening all, and welcome again to another amazing CocoaHeads. We're presenting virtually again this month. Definitely looking forward to drinks night later this month and the catch up at the park, which will be really good events coming up. So if you can get along to either of those, do so. But for tonight, I thought it would be worth having a bit of a chat about Core Spotlight, which is something I have been playing around with for an app that I'm building called Ride Stats. So one of the things I do is I do a lot of cycling and I record all of the data. So I thought, well, how can we actually expose that data from an app into Spotlight? And that's what this talk is about. So Core Spotlight has been around for a long, long time, and it is, just a great way to search for absolutely anything and everything on your Mac or on your iPhone, your iPad. It's pretty cool. So let's see how we can implement it, what's some of the new stuff, and everything about it. As always, ask questions in the Meetup channel on Slack. If I see it come through, I might answer it as I go. Otherwise, I'll be, hanging out in there at the end and answering any questions. So what's new? As I said, Core Spotlight itself has been around for a long time in macOS and iOS, but there is something new that was announced at WWDC this year, and that is integration with Core Data. So 2 amazing bits of tech from Apple, and it allows you to index all of your data that resides in Core Data and expose it to Spotlight with some it's actually fairly straightforward and fairly easy. And then you've got, well, now that the data's there, where do you go from there? So let's have a look at how to get this all going. First thing we need to consider is our application setup. So what we need to do is, one of the things that is definitely recommended for your core data is to make use of app groups. So put all of your core data files into the app group, and by doing so, all of the sandbox restrictions and everything like that, you can work with them fairly nicely, and your quick look preview extensions, which are been around for a while, but actually that's what works for Spotlight previews. They need to access your data, and that requires that your core data store actually resides in an app group. Another thing to Enable is your core data model. So with all of your models and then the different elements in that model, if you want to index it in Spotlight, you just check the checkbox that says index in Spotlight, and away you go. The NS persistent store description, that's something you will have to set up, and you want to set it up with enabling history tracking. So what history tracking will do is it will record all of the changes, and as those changes get made, the core Spotlight delegate can, NS core data core Spotlight delegate, which is a mouthful, will come along and see all of those changes and do your inserts into core data, your deletes, everything like that. So yeah, make sure you enable persistent history tracking. The other slight gotcha is when you look into the quick look preview extension, it can only have a read-only view of your app group and the data in there. So what you need to do is when you load up your core data store is say, this thing is only read-only. Otherwise, it will crash and burn, which is, yeah, something I had to deal with. But calling it out so that you don't have to and you can get away with, yeah, making use of it without that hassle. Next thing to chat about is the CS searchable item attribute set. So core Spotlight searchable item attribute set. A lot of these types are definitely mouthfuls with how they are written. It is very much an older Objective-C framework, but we make good use of it in Swift, and that's really nice. So in order to present the items in Spotlight, we need to define their attributes. When you make use of the core data core Spotlight delegate, you can define all of these attributes that relate to an NS managed object. You first create the attribute set, then you set things like your identifier, which is a unique identifier. You see on the screen there how it's got a title with location and a date. That is the title. And then you can also put in some thumbnail data, which is the image next to it. In my particular case, the thumbnail data is just a representation of the route that was ridden. Next thing to look at is the quick look preview extensions. So these are separate for Mac OS and iOS. You need to add a target for each platform you support. Now within the settings for the preview extension, just make sure that you add the apps groups capability, and you define the app group to be the same as your main app target. Make sure all of your core data stuff lives in the app group, and away you go. It'll be very straightforward. Other standard things to do when dealing with extensions, make sure that your version numbers and everything like that are all set up and the same, and away you go. Now, presenting Swift UI from within the preview of the Spotlight search results, it's not as straightforward as you think. I spent a bit of time complaining on Twitter, complaining on various Slacks as to why doesn't this work? There's a reason for it, and that reason is you need to define a subclass of either NS hosting view or UI hosting controller with the actual type of view, this type of Swift UI view that you will be displaying. So once you've done that, you then go and add the hosting view subclass to the view, just in the standard view.add subview. Make sure you set the frame, and the handler there is from the function which is being called, and that tells Spotlight that you have gone and prepared all of your data there. If you look at the code I've got there, I'm also doing things like making sure the core data store is loaded. Otherwise, we won't have any data. So yeah, all depending on your use case, this is how I managed to solve that problem. For the UI kit iOS side of things, using a UI hosting controller just means that you need to add everything as a child view controller, and away you go. It all works. So how does it look? On macOS, everything is really good. You can present as much information as you want. The preview for macOS is interactive. You can zoom on the map. You can scroll up and down in the view. It's all really good, really detailed, because that's the environment that the Mac provides. iOS, on the other hand, as you saw before on a previous slide, it just presents pretty much a table view item there with basic details. When you long press on that, it will present the preview. That then is a non-interactive preview, so you can't do anything around scrolling or anything like that. So as far as what do you present there, just make sure that what you've got is something that makes sense. It presents as much of a preview as you can, and away you go. Now, what good is showing it in Spotlight if you can't then interact back into your app? So how that interaction happens is via NS user activity. NS user activity was around for things like handoff. It's also used for Siri. And in this particular case, it's used for continuing a Spotlight searchable item action. If you have set up your Swift UI app as a Swift UI app, then on the app type, you can put the function on continue user activity, and you get the option of saying, this is specifically for searchable item action type, and away you go. If you're in the old style of your app delegate, you've still got the continue user activity there, but you have to do a bit more work around making sure that it's the actual right type and stuff like that. The user info on the activity will contain an identifier. If you're using the core data, core Spotlight delegate, then the identifier ends up being the managed object ID. So it's very straightforward, very simplified, and you can do with that identifier, that object, what you want in order to navigate the user to the correct location in the app. And that is all I have for this evening. Domo arigato gozaimashita.
Thanks, Matt. Thanks very much, Matt. That's cool. Now, what's next? Dependency Injection with a Service Locator Pattern by Rob Amos. Take it away, Rob.
Thank you, Hugh. Hopefully, yep, looks like everyone can hear me. I can see myself on the screen. Everything looks good. That's a good start. I think, as Hugh said in the introduction at the beginning, this is something that's come up on a couple of the Slack teams that I'm on in recent weeks. So when we were short a presenter or two for this month, I thought it might be a good topic to actually take a look into. So this topic, or this talk, will really be some of the. I'm going to talk through it as some of the downsides to your traditional dependency injection model, and the upsides and downsides of using a service locator instead, how that service locator works, and then I'll walk through an implementation that is based on one that I've built actually twice now, once for the day job, once for the other jobs as well, and we can talk to some of the benefits of how that actually looks in practice. So your traditional dependency injection setup, you have all of your dependencies as the properties on your type that you're using. You declare them as they always look, like just a flat list. I have seen ones, and I've used ones myself, where it's done by passing a dependencies object around, and then you actually have protocols, and you can then combine those protocols on your dependency object, and that's how you declare your dependencies. Same problem still exists. You just end up with a long list of protocols instead of a long list of properties. So continuing that first one, you would then inject all of the dependencies that you need into your initializer. And that's obviously going to get quite big the longer you have. I took this off an actual project. So this is an actual project dependency graph when I first started doing Swift and was trying to do proper DI the whole way down. So this approach has its benefit. It's probably should have been the first one on the list, but your dependencies are well understood by the compiler, which means they're resolved at compile time, and if something's missing, the compiler will tell you. Also, all of your dependencies are available during initialization. It's quite easy to reason about and understand. You can see that your type has the exact list of dependencies right there because you can see them as properties on your type. And your dependency graph, for the most part, is self-documented. You still have to dive down the levels a little bit, but you can see go back to the previous example. The localization manager in this case also has a dependency file manager because it has file access, and loader and so on and so forth, and they all talk to each other. But you can fairly easily, by following, by right-clicking on your type and going to the definition, you can follow that all the way down. And again, the compiler ensures that your dependency graph is solved. It's not something that you need to worry about too much. But it does get messy. If you've got a view that hangs all the way down the very, very bottom, or you've got a service, or you've got however your model's set up, and your dependency container, wherever the dependencies start, is at your app delegate. You then need to pass that, all the way down from view to view controller to view controller to view controller, just because this one child needs that dependency. And so, it gets messy. It gets hard. It can get hard to follow. And by actually having those dependencies passed around like that, it makes code reuse more difficult because you need to think about, before you can pick up let's continue the view controller example, before you pick up that view controller and move it to a different part, you now then have to solve the dependency graph for it as part of the compiler, which may be easy depending on how you pass them around. But again, it's not something you want to have to think about in code reuse. You just want it to be able to pick it up and go. So a service locator is not something I'll click the right button eventually. I forgot that when the picture-in-picture goes away, my voice goes with it. So service locator pattern is not something that I've invented. It's been around as an enterprise pattern at least the 70s, if not earlier. The basic concept is you have a locator in the middle, and then your classes or your view controllers, whatever you like, uses that locator, and then you pass into it you tell it what you want, which service you want, and it just goes and grabs it, brings it back to you. Very, very simple. And the key benefits of that, you have a central registry of all your dependencies. To back so you can see my wild hand movements. I am. So you have a central registry of all your dependencies, and that registry becomes the only thing that you need to inject into your stack. So you can inject it at the top, you pass it down to each child view controller as you go, or view models if you're doing a view model-based hierarchy, or between different services if you're doing a service-oriented architecture, those sorts of things. And then you just ask that service registry to give you that dependency. And that makes for a lot of really good benefits, which I'll talk to in another slide a couple down. But one of the key callouts is it's really easy to replace dependencies when you describe what your dependency is. If you describe it as a protocol, then it's very easy to just put in a mock version of that, mock implementation of that protocol straight into the service registry. All of your stack needs to know nothing at all about that. It just knows that, hey, I need to get dependency X. Dependency X comes back and it's a mock version. Nobody knows, makes it easy to test. But it can be like, it's not perfect. You do need to be careful of retain cycles at times if you're using something that is a dependency that in itself has dependencies. So I think I have a slide about this a bit later. I'm not sure actually. But let's say you've got following a service-oriented architecture, you have a service, and that service is a dependency of other services and things, so you can actually call into that service and get what you need out of it. And then that service depends on other services. So that service has a copy of the dependency registry that it is also registered in, so you need to be careful of that. Like, it's a little bit harder to maintain. And depending on how you do it, the dependency graph can become quite opaque. You really have to then click through and read each implementation carefully to see what it depends on, and then keep going down the stack that way. It can get quite hard. You can write some tooling to help fix this, and this is something that I'm looking at doing at the moment, and I'm very excited about Doxy's symbol kit, because that looks like that would make that a whole lot easier to go digging through this and generate a dependency graph. I'm looking forward to getting to do sometimes. So as I usually do for these, I pulled some code out of my personal toolbox and stuff that I'm using that I take with me to each project that I go to, and I've published it online, so into GitHub. So today, pleased to introduce depends. Oh no, wait, that's the wrong slide. As much fun as comparing adult incontinence with dependency injection might be, this is the action. So it's just up on unsigned.app/depends. I'll post a link to that in the chat at some point after this. I haven't actually had a chance to write the README up for the description yet. You can probably consider the next few slides to be most of that README, but I'll take some time tomorrow and flesh that README out. The code in there is fully formed. It's based on work that I've done, and it has a version of that. So I wrote this version, and then a derivative of that now in place, and it's in at a big project that has a lot of dependencies, and I'll talk a little bit more about that later. So this is our over there. So it's actually not too dissimilar from that very first slide that I had, except now we have a dependency provider, which I'll talk to a little bit. You can see we have a dependency registry that we keep there. And then we use a nice little property wrapper called app_dependency, where you pass in the dependency that you're looking for, and you get access to it directly. So it's as close to the original as we can get, really. It's just instead of having pass all of those properties in during the initialization, they're looked up live they're located, I guess, to use the service locator balance a bit more. They're located from your dependency registry as and when you need them. And then, so yeah, obviously we don't need to initialize our type anymore with the full, what do I call it? Tester. We don't need to initialize tester with that full list of dependencies anymore. We just pass in that dependency registry, and we can obviously assign that and then look it up afterwards. So how we actually go about declaring dependencies with this approach is pretty basic, and I've taken the example here of wrapping file manager. So one of the first things that you'll do if you have any testing that needs to access, or any code that needs to access the file system, is you'll start with a file manager, and then at some point you realize that you need a mock file system. So you then write a protocol to wrap to basically implement what's in file manager, which is what I've done here. So I call it file manager protocol. Formed. Let's pretend I wrote some methods in there. I've skipped them out for slide convenience size. So we'll pretend that file manager will conform to file manager protocol, of course. That's the extension. So then we declare an extension on the dependency key. I'll get into what a dependency key is in a minute. But we declare a dependency on dependency key, extension on dependency key, where the dependency type is the file manager protocol. And then we declare that the file manager static method with a default instance of file manager.default, which is what enables the access to use the app dependency file manager and pull it straight out. So there's one-to-one mapping there between that static property and what's actually passed into the property wrapper to get that property out. So the reason we have a dependency key as a type, and this whole I should actually probably take a step back. This whole way of managing dependencies came about because it's pretty much a blatant copy of how SwiftUI has their app environment. Like that's pretty much exactly how it was implemented originally. There's a whole bunch of new stuff being built on top of that, but the core concept was exactly the same as the app environment for SwiftUI. So we need something to tie that .file name that was in the app dependency to the type. So we really just need that thing that we can do that is generic and can be specialized with a type. And so then that .file manager property is really just pointing back to the to that type. So we know exactly what type to pull it back out, and I'll show you why that's simple in a moment. So this is it, really. We need a name for it, and we have something unique for that. This is so that when we store it in the dependency registry, because the dependency registry is basically a glorified dictionary. So we need that key. It can be anything hashable, really. We've just gone with a name for convenience on this. And then we just pass in that dependency factory. So if we go back to that last slide, you can see when I declared static let file manager equals dependency key with default. File manager.default, that's passed in as an auto closure to the dependency factory. And then when we get to the next slide, if we don't have a dependency registered specifically for that name, so for that file manager, it will use the default, which is this one, I believe. Yeah. So our dependency registry really is just a glorified dictionary. We use string any because we're going to throw anything in there, and we have that string as the key for that. We don't initialize with anything. This is a really cut down version of what's in the GitHub repo. I'm not going to go through all of that because we'll be here till like 9 or 10 o'clock. It's not really that interesting. But there's two main methods on this. One is the register method, where we register a dependency. So that's your instance of the dependency for that particular dependency key. And again, this is all just about being able to specialize that generic and then popping it into the storage using the key that's associated with it. And then the next one out is the get dependency for key method. Again, the key is there solely for the generic, so that we can look into the storage, because remember that our value type in the dictionary is an any. We need to be able to see if we can cast that back to the original dependency type. If that's successful, that means that it was registered with the correct type, and we then just return that straight to the user. Otherwise, we use that dependency factory, and I think I've actually got a file error there because I've called it make dependency instead of dependency factory. Yep, that's fine. So we make that dependency using the dependency factory. We register it so that it's there for next time, and we return it. Now, registering it's important, especially when using reference types, because I've run into this hard way where you just get ephemeral instances of dependencies that are returned, because somebody will get that dependency, it returns the default value. But if you don't save that the default value, then the next person that requests it is going to get a different, which can lead to some wildly entertaining bug reports and some long nights of diving headfirst into code, trying to figure out why. So yeah, dependency registry is just a glorified wrapper around the dictionary with some generics thrown in to make it all nice and easy. The magic glue comes in the next little bit. So you saw when we declared that tester in the beginning, we had that dependency provider, and that dependency provider is there solely to help the property wrapper work. And all it needs to do is say, hey, at .dependencies, there will be a dependency registry. And that's all that the property wrapper needs to know to be able to actually dive in and get that dependency out live. This is where we're going next. So this is our property wrapper. And if you can see there, the very first thing we do is probably the very worst thing you can do with a property wrapper. And we declare the wrapped value property, that one mandatory thing that must be there for a property wrapper, as unavailable, and throw fatal errors. And the reason we do that is because there's a couple of different bits of magic as to how SwiftUI actually works. But if you use the environment property wrapper in SwiftUI, it doesn't actually map to the wrapped value of that property wrapper. And I'll show you in a little bit what it does wrap to instead. But yeah, so there's a few hacks that they've put in there for SwiftUI. We're pretty sure that they're not going to deprecate those anytime soon, because that would break API compatibility, API stability with older releases. So this hack is reasonably safe to use. But yeah, so we must provide that property wrap, we must provide the wrap value, we must provide an implementation of that, so that the property wrapper can have it, get its type from whatever the wrap value type is. But then we ban all access to it. So if you actually tried to go to, so in the file manager property, if you try to go to _file manager .wrap value, you'd hit this fatal error. Hopefully you also hit the add available filer check so that the compiler yells at you first before it gets to that. But yeah, the other two parts that we have to this then are we need the dependency keys, and then we initialize the property wrapper with that dependency. So again, let's say filter manager. My apologies for my terrible code. Unfortunately, when you type code into slides, Keynote is not a very good compiler. But that's okay. We'll get there. So yeah, we get rid of that. And then we initialize it solely with the dependency, so we can get that dependency key, which has the generic type. So the property wrapper knows what it's specialized as, which means when you go to access the file manager property, we know what type it's supposed to be. So the magic is this bit. Now, if you like C++, you can actually dive into the Swift compiler and find out where this all is. There's another version of this for projected properties as well. And if you search for some of the terms on here, you'll find the Swift forum thread that talks about this, and I'll actually probably drop a link to that in the Meetup channel as well. So this is a public static subscript, and it actually, what it does is it allows the property wrapper to see its parent, so to see the type that it's embedded in. So if I go back to this one, so in the at dependency property wrapper for file manager, when we come to that enclosing self type, it would be tester. So it allows the property wrapper to see the type that it's embedded inside, its property inside of. And in all of the examples they've got for that, they call it enclosing self. So it is the self that encloses the self to a degree, I guess. But the first parameter to that method is what they call observed, which is the tester type that wraps it. And then it provides two key paths. One is for how to get to the wrapped variable. So it's a key path that goes directly into the wrapped variable, so that that's /dot wrapped value. And then there's a storage key path, which I don't remember off the top of my head. The storage key path is the key path to get to the property itself, if that makes sense. To get to the property wrapper itself. So probably should have pulled an example out of this, so it would have been very helpful. So let's assume that, going back to our tester example, this is called on dependency. The first parameter observed is an instance of tester. The first key path, the wrapped key path, would be, so let's say we're talking about file manager, would be /dot file manager dot wrap value _ file manager dot wrap value memory. And then the storage key path will be /dot _ wrap file manager. So it's pointing back to this is really bad at explaining this, aren't I? First key path points to the wrapped value directly. Second key path points to the property wrapper itself. So you can go then, and I've got it in the middle there, you can subscript the observed object, which is itself, so the tester, the wrapped tester, to get to the actual property wrapper. So to get to the properties on the property wrapper, you can subscript the observed value, or that outer type, using the storage key path. That'll get you back to the property wrapper. And then we grab the key off that because we declared that here. We have that key on there. And then we actually go back to the parent. We talk to and this we declared it here. So you can see on this declaration that the subscript only applies where the enclosing self is a dependency provider. So we know that the instance that's passed in, the observed instance or the tester instance, for our example, is a dependency provider. So we know we can grab that dependencies of the property and then ask it to look up the key from the property wrapper itself. Yeah, I definitely should have rehearsed this and then put some better naming or examples into this. There's actually a bunch of comments in the code on this particular method as to how and why it works, including links back to the source. So I'll post that as well. Okay, so step back from that implementation detail for a second. So this is that thing that I mentioned before. We can, now that we've got that file manager protocol, we can very easily create a mock file manager. Here's an example of how you might do that, where you have a file system that just has keyed based off the path and the actual data contents of what's inside the files. You would then implement the various methods of saying, file exists a path, we're just checking to make sure that path exists in the array or not, in the dictionary, sorry. Your contents of file at path is then just returning the data that's found at that key, so on and so forth. You can almost implement a full all the important parts of a file manager anyway, if you don't care too much about resource types and symbolic links and other fun things that, yeah, anyway. So an example of testing for that. So let's assume that we've got a my class. Probably should have continued the tester examples here again, but we assume that my class has a dependency on file manager. So it has that at dependency dot file manager, the property. We would then declare, the usual. We declare a dependency registry. We declare the different dependencies that our service needs. We set up that dependency registry. We create the instance of the mock file manager with an empty file system, and then we call that register method that we have put the file that our mock file manager instance into the dictionary that's inside the dependency registry at file manager's key, and that makes it nice and easy. And then when it actually comes time to doing the test, we can create an instance of our my class. We pass in that dependency registry that we've already got. We can then set up our mock file manager by putting at /hello.txt, putting in the hello data blurb into that, and then assuming that we have a method called getHelloMessage that goes into the file system, reads /hello and returns the result. You can then easily do it that way. And my class is none the wiser as to whether it's been passed in actual file system of the file manager or if it's been passed in the file manager. And it doesn't just have to stop at one mock file manager. You could have 20 different file managers sort of thing. I'll talk a little bit in a minute about some of the different types of dependencies that I put into this sort of thing. But one of the ones that we do is for like error reporting, for example. You could have an error reporting dependency that you use. And part of that is you can have a recording instance. And all it does is records all of the errors that were sent to it. So you can then assert that there were no errors sent to it during the test, or you can assert that certain errors were sent. Or you can have, if you don't care about the actual error reporting, you just need to pass it as a dependency to satisfy something else. You can have like a void error reporting set up that just dumps all messages into the void because you don't care. It's not the purpose of your test. That sort of thing. You have different implementations as you need to. So some of the benefits of this is you only need to pass around the service registry instances. And if you embed your dependency provider in your base class for things like view controllers and view models and any services, if you're using a service-oriented architecture, those sorts of things, then it really becomes quite transparent. The list of dependencies is as easily obtainable as our first example. We don't have, so you can actually just go into your types and look for the app dependency anywhere that's used, so on and so forth. As I said, I'm working slightly on see if I can use Doxy symbol kit to dive into each type and pull out all of those dependencies directly and then print them out in a pretty graph. That might come one day. And as I said, we can use protocols in there. That's not a benefit of this approach, but if it's a benefit of Swift itself. But if you put it in there and do it right, it can actually be quite flexible and quite powerful. Some of the drawbacks of this, runtime protections now, or runtime errors, assertions in particular, guard against missing dependencies. So in the implementation that's up on GitHub, if you have a nil service, it will throw a fatal error. That can be quite okay too, as the usual. So if you didn't provide a default in the declaration at the dependency key, it will throw a fatal error, and that can be okay because as the usual adage goes, fail early, fail fast. Make sure you test it, that sort of thing. And typically, in most cases, all of the dependencies are loaded pretty much as soon as the app loads. So if it crashes when the app launches, you find it pretty quickly, and hopefully that doesn't get through your testing, and your UI tests or your unit tests, whatever tests you're doing. As I said, the full dependency graph can be harder to visualize because it's not enforced by the compiler. So that's a big downside. But again, the more you build with it, the more you get mature with it, the better it actually you become at handling these sorts of things before they become a problem. And circular dependencies can be harder to spot if you've got that file manager service that has a dependency. Let's go back to the loader one that I mentioned. In the example, if we have that loader that depends on file manager, but then file manager uses loader to actually go out and find something or those sorts of things, it's not, you don't have that compiler protection of telling you where you've got something that's missing, because you can't initialize that without that sort of thing. So it can be much harder to spot. But again, there's a bunch of other non-technical solutions you can have to that around making sure that things are only registered at a certain time. Those assertions that I mentioned, that sort of thing. That's more around discipline than it is around compiler enforcement. But I really wish I could get the compiler to enforce it. That would be lovely, but fortunately not possible at the moment. So going deeper into this, so one of the implementations I have of this is now up, has just passed the 100 different services or dependencies path. And it's fairly seamless and fairly invisible in practice. Like, we just kind of forget that we're passing dependencies around at all. You can just write your @dependency and there it is, it's there. And if it's not there, it's going to yell very loudly about it. And it gets pretty simple. It gets a lot simpler to maintain than having to see all of those, either, the dependencies themselves injected into methods, or a dependency container that has a list of 100 different protocols that it's conforming to, so you can pass it around. It does get fairly good the more and more you use it. As I said, it's quite flexible. You can swap the implementations based on conditions. Like if you've got a so the example I always give when I'm talking about this is like, well, different authentication providers. If you've got, you might integrate with like an auth 1 through auth 0, or you might integrate with like AWS or your Google Clouds or your Twitter or your social media login, those sorts of things. You can hide those in different implementations of the same dependency, and then depending on that, you just register if the user when you actually pull the user out of the keychain and go, oh yeah, they've logged in with Facebook, you can then just go, cool, Facebook login service is the one, and then the rest of your code just works. It doesn't have to know anything at all about that. It's architectural in that it was designed originally to support a service-oriented architecture, which goes a lot well with what we do with, your smaller views and that sort of stuff. A service-oriented architecture is not really, it's just a nice way of saying each service is small and single purpose. You have so the authentication example I just gave is one. You could also have stuff thanks to an API. You don't mix and match. That allow them to use the dependency container to get the bits they need. It's the same when we talk about imposing views and that sort of stuff. Keep everything small, and this goes into there's really no penalty for splitting a service into 2 or 3 pieces instead of having one big one, because it's not going to pollute the global namespace of your dependency container because of the protocols or your properties. In depth, so you can fan out changes along your dependency graph. So the example I use there is if you've got, again, those, like if we go to a good example here, like push notifications, for example, you can load the correct version of or you could load the same version of a service in for. No, this is a bad example. We'll continue with it anyway. And you can depending on whether you're in a development or a debug or a release build, you can specialize your service with the correct what's I'm looking for, whether you're in the sandbox mode or not, those sorts of things, and then that can publish the changes that it needs to other services down the dependency graph. The other example I use for that is environment. So if you've got like a production environment and then like a staging and a testing environment or a development environment, and if you've got an environment manager that sits at the top of your dependency graph, and then everything else just hangs off that. Then the next layer hangs off those. And it can be the one that on GitHub actually uses the hierarchy of dependency registries. And so you can actually lazily load or lazily populate those as you go. How that works is we would have, say, a dependency registry at the app delegate level, which might talk to things that are global across the whole app. So like, feature flags. I have a good feature flag library that you might want to look into as well that I've done a talk on here before about. Small plug. But we also have things like error logging. If you want to wrap UI application and be able to pass that without using that accessing UI application.shared, you could have a UI application protocol, and then you can mock those out and pass those through easily, and that exposes then the UI application instance to the rest of your application without you having to import UIKit everywhere or to access the singleton directly. Another global one is things like analytics, stuff like that. And then if you are a good iOS citizen or a good Swift UI citizen for macOS, you're going to have a scene anyway. And then you would have a second dependency registry at that scene level, which has things that are specific to that scene. And it has a parent relationship back to the one at the app delegate. So if you needed to use if your code is at the scene level, and you needed to access, say, the error logging one, you would just talk to your local dependency registry. If it doesn't have it, it will go up to the app delegate. It means then that you can override ones from the higher level with specialized versions. But it means that you can have multiple scenes work independently. So if you've got a multi-window application for macOS, and you want one window to be pointing to production, but you also want your developers to be able to have a second window or a third window that have different users logged in or different environments set up, those sorts of things. And then you might have another one down is once you've actually established, say you've got your scene, you've associated a user with that scene, you then establish a session with that scene, you have your dependencies that require, say, credentials to be able to access the backend APIs, or to be able to decrypt the local database if you're doing that sort of thing, or if you have, again, good practice is to have, if you're a multi-user application, you have separate databases for each user, that sort of thing. But it means that you don't need to know anything about the structure itself. You just talk to the one at your level, and then you pass it back up as you need to pass it back up. I see some people have been pasting links. Thank you very much. And that's everything that I've got for this. As Matt said, I'll be in the Meetup channel. I'll also be hanging around on Zoom after this, if you have any questions. Well, thank you. Back to you, Hugh.
Okay, well, thanks, Rob. I think we're very close to that at our current client project, and I think I'm going to suggest a few of those approaches. So it remains for me to say thank you once again to our sponsors, the gold sponsor, Itty Bitty Apps, silver sponsors, Latitude Financial Services, REA, and Cognizant. Thanks. So lastly, I want to remind you, drinks night. Oh, so there'll be a Zoom catch-up straight after this. Look on Slack for the link to that. But on Tuesday, the 23rd of November, Imperial Hotel rooftop at around 6, but you can come a bit early or a bit later, doesn't matter. It's a drinks night. That's great fun. Hop along to that if you can. And the family day catch up, just a general hangout in the park, Saturday, the 4th of December, around about midday, Flagstaff Gardens. We had this last year. It was great. Just a casual catch up in the park. Nothing special, nothing stressful. It's just, we're just going to go hang out. We've had a bit of a weird year, so it's great to see everyone. So look for the link to the Zoom on Slack in a minute. And thanks so much for joining us. I'll see you again very soon. Bye-bye.